Today is the 25th of September 2023, and I'd like to give you our first lesson on angles. Okay. Before I start, thank you to everyone who has been watching our videos. Okay, I really appreciate it. Please consider subscribing, sharing, liking, and following us. Okay, I'll really appreciate that. I normally write in the comment section, please follow my notes /scripts. Okay, you will hear me say this over and over again, because there are chances are maybe this is your first time watching the video. Okay, so for instance, this is a 10, that is a 11. So if you hear me say 1, here is 1 plus 10 is 11. That is x squared. Okay, that is 36 minus 36. So if it comes out as maybe 6 or 3, please follow the notes. Okay, I'll appreciate that a lot. Beware of scammers. Okay, that's why I say that even though I'll appreciate for you to share and subscribe, if it's your account, please, you can consider doing that. But if it's not your account, maybe it's for your parents, or you are watching with a friend, and you should please ask for permission of the account holder before you subscribe or share or like. I guess make sure that and follow. So just make sure that you have asked for the permission, or you can ask. Some parents don't want to do that because social media is now a big thing. Okay, so I understand that. Okay, but if you are using somebody else's account, ask for permission, okay, before you share, like, subscribe, and follow. Okay, thank you very much. And please beware of scammers. Now, recap. We've been learning about functions, okay, and we denoted them by f of x. So it's like an operation or a machine. So x is our input. What comes out using that function is our output. So for instance, if you put x equals 1 and you get, say, 11, then 1 is your input, 11 is your output, and x plus 10 is your operation. So let's look at an example, a simple example. F of x equals x plus 10. Okay, so when x is 1, when you put in x equals 1, f of 1, which is your output, becomes 1 plus 10 equals 11. When you input x equals 2, f of 2, which is 2 plus 10, under this operation, x plus 10 is 12. When you input x equals 3, f of 3, which is 3 plus 10, under x plus 10 will be 13. Okay, so wherever you see x, you put it back into x plus 10, whatever they are telling you x is, and then your answer is your output. This equation here is your operation. Okay, x equals 4, so f of 4 will be 4 plus 10 equals 14. X equals 5, so f of 5 equals 5 plus 10 will be 15. Okay, so this is what we've been doing so far. You can watch last video and you see everything and the functions. Okay, so now today's starter, we want to have a quick look at difference of two squares. Okay, because we might need it in the future. The last time I introduced you to this, to two videos. One, I think, is substitution. Okay, so let's look at s plus 1, x minus 1. So it means x would divide everything in this bracket, plus 1 would divide x will multiply everything in this bracket, plus 1 will also multiply everything in this bracket. Okay, now x times x is x squared. X minus 1 is minus x. Remember, I work on integers. Plus 1 times x is plus x. Plus 1 times minus 1 is minus 1. Okay. Now, minus x plus x becomes 0. So our answer is s squared minus 1. So this is where the name comes from, the difference of two squares. So s squared minus 1 squared. 1 squared is also equal to 1. So s squared minus 1 should give you x plus 1 into bracket x minus 1. And I stress that your ability to see this and see the answer as this is very important. Okay, we've done some algebra work, but if we start doing difficult algebra work, you might have to see this and break it down as that, or you might have to see that and replace it with this so that you can simplify your answer. Okay, so today I'm just doing that because I don't want you to forget. X plus 2, x minus 2. Okay, 2 squared is 4. So difference of 2 squared again, s squared minus 4. So from here, that is our answer. But if we are still struggling with that, we are going to break it down. Okay, so x times x is x squared. X times minus 2 is minus 2x. Plus 2 times x is plus 2x. Plus 2 times minus 2 is minus 4. So s squared minus 4. So now here the difference of 2 squared, x minus x squared minus 2 squared. Okay, so x plus 2, x minus 2 will give us that. And the last video, I remember, and I said, assuming you had s plus 2, x plus 2, your answer will be different. Likewise, if you have x minus 2, x minus 2, your answer will be different. Your answer from x squared minus 4, that will be x plus 2, x minus 2. Okay, now x plus 3, x minus 3. So there's a plus and there's a minus. So straight away, our answer will be x squared minus 9. So again, another example of difference of 2 squared. So if we simplify, we have x times x is x squared. X times minus 3 is minus 3x. 3 times x is plus 3x. Plus 3 times minus 3 will be what? 9. So x squared minus 3x plus 3x is 0. Remember, work on negative integers. So x squared minus 9. Now let's look at the fourth one. Here again, difference of 2 squared. So I didn't break it down. X squared is x. 16 squared is 4. So one of the brackets will be x minus 4. The other will be x plus 4. Okay. If you like multiply through, you will get that. Now x plus 5, x minus 5. So because there is a plus and there is minus, it's also difference of 2 squared, because 5 times 5 is 25. So my answer will be x squared minus 25. Another example, x squared minus 36. 6 squared is 36, or the square root of 36 is 6, plus 6 minus 6. Okay, so 1 will be plus and 1 will be minus. So x plus 6 will be in the first bracket, or x minus 6. You can bring the plus or the minus first, it doesn't matter. Okay, so this is my starter for today. Okay, I want you to go. I've done it with you a couple of times. Okay, but I don't want you to forget. Okay, so have this, have a look at it again. Okay, and hopefully if we start another set of algebra work, we might need this to help simplify our answers a little better. Now today we want to look at angles. This is our introduction to angles. So the first one is a right angle. Okay, or assuming you have a right angle triangle, you have a line drawn here, so you have 3 angles, but the right angle is 90 degrees. This is the sign. So immediately you see this sign, even if they don't write the 90 degrees, you should know that it's a 90 degrees. So if they gave you an angle this way, that way, if this is 90, the whole angle should add up to 180. So the top and the down part will be 45 each. Second is angle on the straight line. Okay, an angle on a straight line is 180. All this I've drawn is not to scale. Okay, so if you have an angle on a straight line, it's 180. Now 3, I want us to look at parallel lines. So like the end of two roads, okay, they are parallel, they are traveling in the same direction, because we will need this to talk about other type of angles, okay, and I'll have to show you which one are equal and which ones, that when you start solving complicated angles question, you can apply that to find the missing angles. Okay, now, so this is your parallel angles, this one here, they're traveling in the same direction and they are parallel. It's not to scale, it's guess eye judgment. Now, the fourth one is the full circle. The angle inside the full circle is 360, or the angle at a point. So if I take this point and I go all the way around, it's 360. Okay, so it's 360 degrees. This is what I mean. Okay, so everything I've said so far is in degrees, not in degrees as in temperature, but degrees as in angles. Okay, so that's our fourth one. Now let's look at the fifth one. Okay, angle in a triangle adds up to 180. So angle ABC should add up to 180 degrees, that one. Okay, your answer should always be in degrees. That is the symbol. We did this in mathematical symbol. Now, equilateral triangle. Okay, their angles, they have all the three angles are equal. So we put this arrow, because if the angles are equal, then the length is also equal. This is not to scale, but with eye judgment, you can see that that is 60, that is 60, that is 60. Okay, so it's called equilateral triangles. So the angles are 60 each, they add up to 180, and the length, okay, are also equal. Now, the seventh one, isosceles triangles. Okay, here two angles are equal, so you can have this angle and that equal, and that one is not. Okay, because this angle and this angle are equal, the length here is equal. So the angle in a triangle adds up to 180. So if you know this, it means this is the same as that. Okay, so if this is 20, that will be 20. Okay, and the angle in the whole triangle is 180. So if this is 20 and that's 20, then this top part will be 140. So with isosceles triangle, two angles are always equal. That's why we have guess 2 of this. So if the sign is here telling you this, then these angles are equal. Okay, assuming the sign is there and there, okay, then it means this and this are equal. Okay, that is isosceles triangles. Now, acute angles, they are angles less than 90. So any angle from 0 to 89 is called an acute angle. As you can see, from here to there is about 43 degrees. So it's less than 90. So it's an acute angle. Okay. Our next one, obtuse angles. Okay. They are more than 90 but less than 180. Okay, 90 degrees is a right angle triangle. 180 is the angle on a straight line. So look at this. This one is more than 90 degrees. Okay, but less than 180 is not up to a full straight line, so it's called an obtuse angle. Okay, now let's look at the next one, reflex angle. More than 180 degrees but less than 360. Okay, so more than 180 degrees, which is a straight line, but less than 360. So if you can see, this is more than 180, okay, but it's less than 360, and these are called reflex angles. Let's look at a few examples. So with what we've learned so far, we are going to solve some questions. Okay, so you have find A. This is not to scale, but that's 44 degrees, that's 85 degrees. Okay, degrees as in angles. Find A. So you know total angle in a triangle is 180 degrees. So to find A, we need to add 44 plus 85 and subtract from 180. Okay, so A degrees will be 180 minus 85 plus 44. Okay, so 85 plus 44 degrees is 129 degrees, and when you subtract from 180 you get 51 degrees. So A, the angle, is 55 degrees. Again, not to scale. Another example on a straight line. Okay, now we know that the angle on a straight line from this point all the way around is 180. Okay, so if we need to find this angle A here, okay, then we need to subtract 32 from 180 to find A. 180 minus 32 is 148 degrees. So this angle here, A, is 148 degrees. Again, not to scale. Okay. Another example here. Okay. So find A. A is this bigger angle here. Okay. And that is 24 degrees. Now, we know the angle at a point is 360. Or if you take this as a circle and you move all the way around, it's 360 degrees. Okay, so A degrees will be 360 degrees minus 24, and that will be 336 degrees. Another example here. We have a triangle again. These two signs tells us it's an isosceles triangle. So two angles are equal. Because the sign is here, we know this angle and this angle are equal. Now we know this is 84. So straight away, 180 minus 84 will give us 96. Okay, so if we want to find for each angle, we divide by 2. So A degrees is 48. So this is 48, that is 48, and that is 84. If you add the three angles together, you should get 180 degrees. Okay. So here, I've just tried to introduce you to the type of angles you may have to work with. When we start looking at parallel lines, we will see corresponding angles, okay, and other type of angles. Okay, this one, parallel lines here. This one here. Okay, we'll see corresponding angles and other type of angles, and I'll show you how to use that to solve complex questions. Now, even though it looks like it's simple, your ability to know when to apply what is very, very important. Okay, you should know when to look at the angle and say that, oh, these two lines, so it should be an isosceles, because there are chances that you might see this angle in a triangle. Okay, so you might ask to find another angle, but you might have to apply this knowledge to find the other angle. So with everything I've shown you today, I want to have a good look at it again. Okay, tomorrow we'll do our second, we'll look at other angles as well, and we'll do more examples. Okay, but everything I've shown you today, right angle triangle, equilateral triangles, reflex, obtuse, acute angles, you will need that knowledge to solve and deduce other angles if they give you a complex diagram. So yes, so even though today's lesson looks a bit simple, this is just the introduction to angles. So go and have a good look at it. Okay, make sure you understand this concept so that tomorrow, whatever we learn, you will build on that, which will help you look at a figure and say that, oh, I apply this to get this, and when I finish reducing that, I'll use this angle to find that part and then find what I'm being asked to do. Okay, so yeah, today we've done a recap on functions from last lesson. Okay, and we've done a simple example. We looked at this data again, difference of two squares, okay, to help us in our future, so that we don't forget in our future set of algebra work, okay, and to solve some questions, okay. And then I've introduced you to some types of angles and lines, and I want to go and have a very good look at it, okay. So thank you so much, okay. Thank you so much for watching today's lesson, and I'll see you in the next.